पिछले वीडियो में हमने कंपोजिशन ऑफ फंक्शन और इन्वर्स ऑफ फंक्शन के बारे में पढ़ा था। जरा सा उसको रिवाइज कर लेते हैं। A function f from x to y is invertible if there exists a function g from y to x such that g o f of x is equal to ix and fog of y is equal to iy, where ix and iy are the identity for x and y respectively, such that g is called the inverse of f and written as g is equal to f inverse. Using the same definition, we'll solve this question. The question is, consider a function f from r plus 2 close interval 4 to open interval infinity given by fx is equal to x square plus 4 so that f is invertible with the inverse of f inverse of f given by f inverse y is equal to square root of y minus 1, where r plus is the set of all non-negative real numbers. चलिए इसको सॉल्व करने की कोशिश करते हैं। Let us assume let y is equal to fx, putting the value of fx we get x square plus 4. Solving for x we'll have x square equal to y minus 4. So x is equal to plus minus 4 का square root. Since x belongs to r plus, so only plus sign will be taken. X is equal to square root of y minus 7. Now let us define another function g of y. Let g of y is equal to square root of y minus 4. Now let us find FOGY. It will be f of gy is square root of y minus 4. The definition of fx is x square plus 4. In place of x, it will be y minus 4 square, x square plus 4. Now it will become y minus 4 plus 4, and this plus 4 and minus 4 will get cancelled. You will get only y. So FOG of y is equal to y. This implies FOG is equal to IY, identity function for y. Now let us find GOF of x. Now what is the definition of fx? Fx is x square plus 4. What is the definition of g? It is square root of y minus 4 square root of y. In place of y will have complete x square plus 4. X square plus 4, this is y minus 4. Y minus 4, it will be equal to square root of 4 will get cancelled with this 4. You will have square root of x. Finally you will get x. So it means GOF of x is equal to f. It means that GOF is equal to IX, identity function in x. So hence we have already proved that FOG equal to IY, and just now we have proved that GOF equal to IX. This implies G is the inverse of F. So F inverse is equal to square root of y minus 4. ये प्रूव करना था, hence proved. Next question is, consider a function f from r plus 2 close interval minus 5 to open interval infinity given by fx equal to 9x square plus 6x minus 6. Show that f is invertible with f inverse y is equal to स्क्वायर रूट ऑफ y प्लस 6 माइनस 1 डिवाइडेड बाई 3। तो इसको सॉल्व करने के लिए वही टेक्निक यूज करते हैं। लेट अस अज्यूम let y is equal to fx. So applying definition of fx on the right side, the definition of fx is 9x square plus 6x minus 6. Transposing this y to the other side, so we'll get 9x square plus 6x minus 6 is not 6, this is 5 minus y is equal to 0. Now comparing this equation with the standard quadratic equation, which is ax square plus bx plus c is equal to 0, this is the standard quadratic equation. We will get a is equal to 9, b is equal to 6 and c is equal to minus of 5 plus y. Applying the quadratic formula, we'll get x is equal to minus b plus or minus under the root b square minus 4ac divided by 2a. So x will be equal to minus 6 plus minus b square, the square of 6 is 36, minus 4, a is 9, c is minus 5 plus y. Now substituting the value of a, b, c in the quadratic equation, we'll get this. b is minus 6, no, b is 6, c is minus 5 plus y, a is 9. So this will become minus 6 plus or minus 36 plus 36, this minus and this minus will become plus 36 5 plus y divided by 18. Now we can take 36 common from inside the square root, and when it comes out it will become 6. Minus 6 plus or minus 6 under the root 1 plus 5 plus y divided by 18. Now 6, now we can take 6 common from whole of the numerator. We'll get 6 minus 1 plus or minus under the root y plus 6 divided by 18. Now we can cancel out this 18 with this 6. Now the value of x will be equal to minus 1 plus or minus under the root y plus 6 divided by 3. Now if you take minus sign here in the second part, the whole expression will become negative. But x belongs to R plus, means that x is a positive number. So both minus 1 and this both cannot be negative number. So we must have x is equal to minus 1 plus square root of y plus 6 divided by 3. So the value of x will be equal to square root of y plus 6 minus 1 divided by 3. This is the value of x in terms of y. So now let us define a function g. Now let gy is equal to square root of y plus 6 minus 1 divided by 3. So now let us find f o g of y. F of gy is this whole expression on the right side, y plus 6 square root minus 1 divided by 3 का function हो गया. Now what is the definition of fx? The definition of fx is 9x square plus 6x minus 5. 9x square plus 6x minus 5. So in place of x, we will write the complete expression square root of y plus 6 minus 1 divided by 3 in the definition of the function fx. So it will be 9 times square root of y plus 6 minus 1 divided by 3 squared plus 6 times square root of y plus 6 minus 1 divided by 3 minus 5. Now it will become 9. Denominator will become 9. A square minus 2ab plus b square. So y plus 6 minus 2 times y plus 6 minus 2ab. This should be a square minus 2ab plus b square. This should be plus 1. This should be plus 1. Now we'll get y plus 7. This negative 2 times root y plus 6 will get cancelled with this. Minus 2 minus 5 equal to y. So starting with y, we get again y. So it means that FOGY is equal to y, implies FOG is identity function in y. Now let us calculate GOF of x. Now what is the definition of fx? It is 9x square plus 6x minus 5. Now what is the definition of g? It is square root of y plus 6 square root of y, that is 9x square plus 6x minus 5y plus 6 minus 1 divided by 3. It will become 9x square plus 6x plus 1 minus 1 divided by 3. Inside the bracket it will become 3x plus 1 whole square divided by 3 minus 1 minus 1. Now the numerator will be 3x plus 1 minus 1 divided by 3, that is 3x divided by 3, and we'll get x. So GOF x is equal to x. It means that GOF is equal to IX. Now we have proved GOF equal to IX, and we have already proved that FOG is equal to IY. Hence G is the inverse of F. It implies F inverse is equal to, we have defined G as under the root y plus 6 minus 1 by 3. So F inverse will be under the root y plus 6 minus 1 by 3. Hence proved. Next question is, let f from x to y be an invertible function so that f has a unique function. इसके लिए हम क्या करते हैं, let us assume f has two inverses, namely g1 and g2. So FOG1 y is equal to IYX or IY, because g is a function from y to x and x is a function from x to y. Since G2 is also an inverse of f. Therefore, G2 f o G1y is equal to G2 iy y, where iy is the identity function in y. Applying associative law for the function we have learned in class 11th, G2 o f of G1 y is equal to G2. Since iy is the identity function, so iy is equal to y. Now G2OF will be Ix, identity function in X, G1Y is equal to G2Y. Identity function maps a variable to itself, so G1Y is equal to G2Y. This implies G1 identity function maps a function to itself, so Ix G1Y is equal to G1Y itself. Therefore, G1y is equal to G2y. This implies G1 is equal to G2. It means that G1 and G2 are not two different functions, they are same. So it means that if a function is invertible, it will have a unique inverse. It means that f has a unique inverse. Hence proved. This much only in this video. In next video, we'll learn about the inverse trigonometric functions.